Today we'll be doing miscellaneous questions based on work, energy and power. All mixed questions of all the types. Start writing. Question number 1. Question number 1. A block of mass m, fast please. A block of mass m resting on a rough horizontal surface. A constant horizontal force is applied. And it starts accelerating. Constant horizontal force is applied and starts accelerating. Find the power at time t. I want to find the power at time t. That means they are asking you about instantaneous power, right? Look at this question. There's a block of mass m and we apply a constant horizontal force over here F. It starts accelerating and it is on a rough horizontal surface. This is rough, okay? Rough means what is going to act? Friction. What is the value of friction? Mu mg, right? Right or not? I want to find the instantaneous power at time t. Instantaneous power ka formula, F bar dot V bar. So I need to find F also and I need to find V also after time t. Now how to do this question? Can I say net force is MA? What is net force? This minus this. Capital F minus small f is MA. So capital F is going to become MA plus small f. So capital F will become MA plus small f is mu mg, right? So can I take M common? It will be A plus mu g. This is the external force which is applied and I got the value of external force. Now after this I need V, velocity. Velocity in time t, can I say V is u plus at? But u is 0, can you see? So at. So V will become at. This is the velocity at time t. What is the instantaneous power beta? F bar dot V bar. What is F bar? This one. And both of them are there in the same direction. So M A plus mu g into at. This is the instantaneous power which is a function of time, right? This is the answer. 1. Getting it? अच्छा, इसी में if they ask you average power, इसी में if they ask you what is average power, suppose. So what is the formula for average power? Work done upon time. Can I say change in kinetic energy upon time? What is kinetic energy? Change. Half mv square minus u square. So u is 0. So I can say it is half mv square by time t. But what is v equal to? At. So can I say it will be half m a square t square by t? It will become half m a square. So this is the average power, and if you need a value, then you can take a from here. A you can calculate from here also. A can be written as net force upon total mass. This A is net force upon total mass. What is the net force? Capital F minus small f by total mass. This can also be written like this. So this can also be written as average power. T should be there, okay? Fine. You all understanding what's happening? Next question. Next question. Find the average power of gravity. Find the average power of gravity of a projectile of mass m. Find the average power of gravity of a projectile of mass m at the highest point. At the highest point. So now question number 2 is telling you that there is projectile motion happening, and the projectile motion which is happening, I want to find the average power at the highest point. So this is there, this will be u. It's theta. It's going to become u cos theta, and this will become what? U sin theta. At the highest point, I can say gravity is acting downward, and this is the maximum height, na beta? Can I say what is this? Maximum height, that is h maximum. And I am going to find average power. What is the general formula for average power at the highest point? Average power का formula क्या है? Okay, average power is work done by time. Work done in going up is going to become mgh. But can I say work done by gravity over here is positive or negative? Negative, because g is acting down and the displacement is up. So this is going to become minus mgh by time. So average power will become minus mgh. H will be the maximum height. What is the maximum height? U square sine square theta by 2g. And the time will become time of ascent, because the time taken from here to here is the time of ascent, and time of ascent is u sine theta by g. So this can be written as u sine theta, and u sine theta will cancel, and g will cancel. So what is the average power which is coming over here? Minus mg u sine theta by 2. This is the average power from here till here at the highest point. Correct. Suppose if they ask you what is the instantaneous power due to gravity at the highest point. Instantaneous power का formula is F bar dot V bar. Can anyone tell me where is gravitational force acting at the highest point? Where is the velocity at the highest point? Right, na? So how much is the angle between them? 90. So Fv cos 90. So instantaneous power at the highest point will become what? Equal to 0. Got it? Start. Question 3. A pendulum is projected horizontally. A pendulum is projected horizontally as shown in the figure. Find the speed of the pendulum. Find the speed of the pendulum when it makes an angle of theta with the vertical. When it makes an angle of theta with the vertical. Also find the maximum angle. Also find the maximum angle to which the string is being deflected. To which the string will be deflected. Now, if I see this is the pendulum they have given you in the figure. It's given a speed u. Speed u. When it is deflected by theta, speed is v. Its length is l. Okay, this one. I want to find speed v. Correct? Now, one thing which I have taught you in circular motion you can do from down to up. Remember? V square is equal to u square minus 2gh. While going up, speed becomes less. Minus 2gh. Na? But h will become L1 minus cos theta, if you remember. We can do this method, the same sum by another method. Work energy theorem. Can I say initial kinetic energy plus work done will become final kinetic energy? Right or not? One method I had done by kinematical equations in circular motion, if you refer. Can anyone tell me what is the initial kinetic energy? Half m u square. Can anyone tell me what is the work done by gravity in taking from air to air? It is raised by a height of h, na? How much is the height of h? Do you know? How much is this height h? It will be L 1 minus cos theta. Everyone is agreeing with me. This is there in circular motion lectures also. So how much is the work done by gravity? Work done by gravity will become minus mgh. But h is what? L 1 minus cos theta. And the final kinetic energy is going to become half mv square. Correct? Half m and m will cancel. Can I multiply by 2? It will become u square minus 2g L1 minus cos theta will become v square. So if I take this, it will become root of this. Correct or not? So same thing it came now. V square is u square minus 2gh. Look. We could have done that by work energy theorem also. If you are understanding. This is the first part of the question. Second part of the question says that how much will it deflect? How much will it deflect? Maximum. So let the maximum deflection beta be phi. Means what? This is u. It will come here and maximum it will stop. Means how much is the speed over here? 0. Means I can say indirectly this is which position? The extreme position. And how much maximum it is deflecting? Matlab I need phi. It means I can apply the same formula but the final velocity is going to become what beta? 0. You understanding what's happening? So can I put v as 0 in the same formula? So if I put v as 0, what will happen? Come on, anyone. If I put v as 0, so v is 0 na? And theta is how much beta? Phi. So just put it over here. So ये क्या हो जाएगा? U square will become equal to 2g L 1 minus cos phi. बोलो. Yes or no? So this will become what? U square by 2gl 1 minus will become cos phi, right? Correct, na? This will be same thing. correct? So what will be phi equal to? Cos inverse of 1 minus u square by 2gl, or you can take LCM also and get the answer. Got it? Come on, start. Question. Next question, pay attention. They are telling you there is an incline of 60 degrees, length is 2 root 3 meter. Mu is 1 by root 3. इसका मतलब what is there? Rough surface is there. You are speeding it up with applying a constant velocity of 10 meter